Lou Siegel. Thank you. My name is Lou Siegel. I'm president of the New York State Marine Education Association. And we're here with one of my old friends, more than 40 years that I've known John from our time at the Gateway National Recreation Area. And then he was my boss for a couple of years at Dowling. At any rate, but most of you, or some of you know John, but some of you don't. And I think it'll be appropriate if I give him a real introduction so that you can find out some of the things that you may not have known about. First of all, John is now a professor of Earth and Environmental Sciences and Biology and Chemistry and Environmental Studies at the Environmental Studies Department at Molloy College. He's also the director of the Center for Environmental Research and Coastal Oceans Monitoring, or CERCOM, which is a field station that he's set up in West Sayville on Long Island. He's held research associate positions at the Wildlife Conservation Society, the Osborne Laboratories of Marine Science, the New York Aquarium, the American Museum of Natural History, and at Lamont Doherty Earth Observatory up in Columbia University on the Hudson. He's co-chair of the Conservation Committee of the New York Explorers Club, or the Explorers Club. John was also a research ecologist for 26 years in the National Park Service, serving as chief of the Division of Natural Resources and as the Coastal Natural Resource Specialist at Gateway National Recreation Area, which is where I met him. He was also a U.S. Naval flight meteorologist on a Hurricane Hunter aircraft, and he has lots of stories about that part of his life. John received his doctorate in environmental health engineering from Polytechnic University. But John is here today to discuss one of his favorite animals, the horseshoe crab. He's a founding member of the International Union for the Conservation of Nature Scientific Specialist Group for Horseshoe Crabs and principal coordinator of several international conferences on horseshoe crab conservation and biology. I had a great time at the conference that was held on Long Island a number of years ago, which was one of the first conferences on horseshoe crabs. His book, Conservation and Biology of Horseshoe Crabs, was one of the initiating factors in conducting the subsequent Asian horseshoe crab conferences, providing considerable support for including all 4 horseshoe crab species on the IUCN's Red List. John conducts horseshoe crab breeding and developmental research at CERCOM and does a habitat inventory of some 115 different locations on Long Island, tracking horseshoe crab breeding conditions and habitats. So I'm sure we're going to be in for a real treat tonight, an educational and informative presentation. And I look forward to hearing some new stuff from John. John, why don't you take it away?
Thank you, Lou. Really appreciate that. That's overly gracious, but thank you so much. And I should note that the CERCOM is the only, in the Western Hemisphere, the only laboratory that its main mission is captive breeding of horseshoe crabs. But I'm going to get into some of the concerns about that because we have, there's always a story behind even statements like that, and I'll go through it. But thank you for this evening. I really appreciate this. And certainly Russell's program at the Museum of Natural History is just outstanding. Any and all of you, if you're involved with education, you're involved with science in any way, talk about what you do. We really need more and more people talking about science than we've ever needed them before. So this is not a presentation about dinosaurs. But now that I have your real attention here, because most people think about dinosaurs as having a predominant force on the earth and certainly on history. And we don't have to compete with T-Rexes for parking spaces or anything along that line. But throughout Earth history, dating back 445 million years, give or take a week or two, those animals would be walking over and around horseshoe crabs. Horseshoe crabs, as an individual organism, is a perfect example of resiliency. And I hope at the end of this talk here, you will see why it should be incorporated in just about any of our educational endeavors. And it is a survivor. It has been here on Earth through 5 mass extinction events. And even the most impacting of paleo history and the KT boundary impact of a meteorite, the Chicxulub crater, it is an organism that even survived that particular debacle, though that's not the most intense, but upward of 75 to 80% of all living things on the planet disappeared due to those events. And some of the mass extinction events of even more than that. But their horseshoe crabs are not crabs and not crustaceans in general, though there's been a debate sometimes over the years with dealing with definitions in crustacean ID. But these animals, if you can see my little pointer here, are related to scorpions and spiders, arachnids. And here's the New York State fossil, Eurypterids, and here's our horseshoe crabs. But the key is the trilobite. And Niles Eldridge and Yumiko Iwasaki from Japan really always would get me more and more excited about trilobites because their molting, their existence in sediments, in mud flats, and their predominance in the early paleo history of the Earth is another part of the contribution that horseshoe crabs provide, because they have survived throughout all this time. Again, they're not in the crustaceans, though they do have an exoskeleton. The trilobites are all gone. Most of the horseshoe crabs are in this category here, Chelicerata and Chelicerates, and we'll talk about what those things are, but they're mostly like the arachnids, spiders, and scorpions. And we'll talk about some of the characteristics there. Just to the bottom side here, their physiology is interesting, and please keep this in mind because I will talk a little bit about the captive breeding program. And one would think that these animals are fairly easy to have reproduce and breeding, but I'll show you some of the concerns. But their physiology, they have compound eyes across the prosoma. The epistosoma is another part of this outer hood, literally, where the animal molts, and that's a critical importance to these animals. 17 molts over 11 years for the females, and 16 molts over 9 to 10 years for the males. So automatically, if you know anything about reproductive biology, you've got a dysynchrony here. You have something that makes it very difficult to even have survival for these animals over that 445 million years, yet they've overcome that. Chelicerates have their legs around their mouth parts, and we're going to talk about their book gills in a moment. And so basically, they are able to remain out of water to a certain extent, and actually then when they come ashore, you will see some of the reasons why they're important for that. And then this particular structure, the telson, it doesn't sting you, it doesn't have any poison in it, it has a couple of primitive eyes called ocelli, like the two that are right here, prominent in the beginning of the prosoma. And it's basically an engineering structure. It helps it right itself along the coast, and it's pretty important in the when these animals start to come ashore, getting caught up in the surf. Again, there's a long and strong history of trilobites, but even if you go to the Museum of Natural History, there's one exhibit showing tracks and trails of horseshoe crabs. That was a note that was put together by Carl Schuster when he was working on his Harvard publication. And the Mesolimnus or Paleolimulus if you were to take that animal and take a look at any one of the 4 species today, uninitiated to horseshoe crabs, you would probably not be able to tell the difference between them. And that is another aspect of their survival. This not the diversity of trilobites, which became very exotic and having tremendous amounts of external surfaces. These animals are basically the same for this entire time in paleo history. And here's a few more fossilized remains of the animal. Now, this slide is always kind of impressive. People look at it and say, oh my goodness, why did they harvest all of those animals? This is in the late 1800s, early 1900s, in just not too far from here, outside of Delaware Bay area. Horseshoe crabs were saved, literally saved, in the early 20th century, primarily due to the fact of finding fossil fuels, because these animals here were chopped up and used for fertilizer. And so that particular process with synthetic fuels and fossil fuels protected the animals. They no longer needed to take them for fertilizer, but just keep that in mind for a while, because the harvest of these animals are still pretty important, and there are impacts on them that have nothing to do with fertilizers. But this is the history of these animals, and that their niche, if you will, and as a coastal, having a coastal environment and the habitat, this fragile edge we call our barrier beaches and barrier islands along our coastline, is the critical area for these animals coming ashore. When I was with the National Park Service, I had a great relationship with our park police, and the U.S. Park Police had a scuba team, basically was for survival and recovery. But every so often, they love the idea of having a project that they can deal with science. And right over here in the Rockaway, off the Rockaway Peninsula, and right in next to the Gil Hodges, under the Gil Hodges Bridge, is an incredible tidal cycle that moves in and out every 6 hours, right, semi-diurnally into Jamaica Bay. And it has a right under that bridge. If you were in a boat, you would have to really anchor yourself down, because you'd be flushed out or flushed in, depending on when you went there. And fishermen use that all the time to come in and out of the bay. But the scuba divers went to the bottom of the inlet, and we would film horseshoe crabs coming out of off the Atlantic and into the inlet. And it was amazing, because all in that very fast moving water coming out of Jamaica Bay were these literally mats, rugs, if you will, extending from one end of the peninsula here in the Rockaway right through up into Jamaica Bay, into the main channel of mussels and blue mussels, and so Mitchellus. And so here we have all of these horseshoe crabs grazing right across all of these mussel beds as they would come in. And it's just an amazing sight, but we don't know where they go when they go offshore. But when they come inshore, they're basically coming into these areas in the inlets and in the embayments. And all of Long Island, as Lou mentioned, we monitor 115 locations. This is our 20th year at CERCOM doing it, from the tip of Brooklyn to the tip of Montauk. And we're basically looking at habitat suitability, and we're also looking at numbers of horseshoe crabs. But in the big picture of evolutionary biology and conservation biology, it is not so much the numbers always that count, because you can have endless numbers of species and they still go extinct, either due to hunting or loss of habitat or a host of other factors. And this is the same thing with horseshoe crabs. But if you're losing your habitat, that's a bigger concern, and we'll see that in a moment. The Long Island coastline is an amazing place. I've always, the short hairs, what are left on my head, stand up a bit when I read about all of this crisis in the shoreline and the coastline and of Long Island. And I don't know where that crisis is. I can tell you right now, the overall biological diversity in the shores from Brooklyn, from New York Harbor, all the way out east, is amazing. Everything from whales to the fisheries. The last 3 or 4 years, striped bass, bluefish, even menhaden, off the charts. All types of activities going on. You can see here all of the shellfish that come ashore after a storm, or so they're out there. This habitat is robust, and we've seen an amazing improvement in a host of things, from dissolved oxygen to water quality in our 20 years of monitoring in the Great South Bay and all of Long Island. If you're interested in what we've been doing, you can get our newsletter, coastal newsletter that talks about the network of protecting these habitats. And this is the habitat. This is it, Spartina marshes along the coast. This happens to be in New Jersey, but anywhere along, if you find these divots, you know that there's horseshoe crab activity. There will more than likely be eggs there. A single female limulus will put between 80 and 120,000. I've heard a variety of things. We don't necessarily count every nesting activity, but we do look for nesting activity. So between 80 and 120,000 eggs in a season. But there are things that can create concerns: structures, rocks, jetties, the riprap, bulkheading, development, loss of dredging activities. All of these things can have influences, but again, the survivability of these animals is amazing, and its resiliency is amazing. And but it's still, we're going to see some of the concerns that are coming about due to habitat in a minute. So mudflats are primary habitat for these animals. As females come ashore first, generally, these animals are represented by what is called sexual dimorphism. The females are always larger than the males. The females, you can know if they're sexually mature based upon the epistosoma has a groove. The males' appendages, first two appendages are little hooks that hook onto the female. It's called amplexus. And at the same time that the female comes ashore, the male is attached. Other males surround the female. These are called satellite males, and all contribute to the reproductive process by putting sperm on these eggs as they're deposited throughout the marsh or the mudflats or along the coastal beaches. And that's another factor associated with its longevity and its survivability. If you've ever had an opportunity, this is Slaughter Beach down in Delaware Bay. Get down there, that's the epicenter for limulus. Get to see in the next month or so as the animals start to come into shore, definitely in the end of May and into June, July. That's the peak period. At the same exact time, another example of this synchrony of individual organisms is as these animals come ashore and putting their billions of eggs into the sediments, females coming ashore first. Here they are in the amplexus and along the mud flats, and then the satellite males. They're growing, they're molting, they're going through what we say in the breeding cycle is really important in this particular entity, but the real entity is not only the numbers of crabs along the shore, but they're little ecosystems unto themselves. They have a lot of attachments to them. They have other organisms that are like the slipper shells here. If you ever see these animals along the beach, you kind of flip them over, but they're predated on by birds. So the numbers, it's a whole ecological interaction. And here's a single clutch from a nest, and they take about 21 days for gestation. And what's prominent in that time are their compound eyes. The telson starts to form. You can see them before they hatch, the larval stages and into the juvenile stages. And these are called instars, each of them the molts. And for whatever reason, we don't really know, this happens in several of the labs that I'll talk about in a minute, but we can get the animal up to about the 10th instar, which usually takes about a year or two in captivity. And then there's mass mortalities. We don't have any idea why that happens. And it's an area that we're still working on. Again, if you've heard of the group Green Eggs and Sand, it's a great thing for students to get involved in. They learn a little bit about, they learn a lot about horseshoe crabs and get out to sites during the summer months. The animals, there are only 4 species of horseshoe crabs on Earth. 3 of them are found here in Asia, the Bay of Bengal, and all the way up to the last island in Japan. But you can literally put a flag on the beach in these areas and not find animals moving about. Here is in North America and in the tip of the Yucatan, as far as Tallahassee in Florida, and up to Maine. And this is the Maine for limulus. The other 2 species, Tachypleus and 1 Carcinoscorpius. And those are found here from the Bay of Bengal all the way up to Japan. In Taiwan, Taiwan has the largest aquarium on Earth in the southern portion of the island, and has a whole wing just for horseshoe crabs. I'm going to show you some things there. The horseshoe crabs are socially ingrained in the Asian society in many of the islands, from Indonesia to Japan to Taiwan, to the coast of China, Vietnam, Cambodia, Thailand, the Philippines. The Philippines, 7,000 islands, and no investigation on horseshoe crab numbers. We had a few Philippine conservation officers come to several of our conferences. We held the first conference was in the United States at Dowling College in 2005. And then in 2009, we were in Hong Kong. And 2010, we were in Japan. In every place where the other 3 species are, the numbers of the animals are just depauperate. They're nowhere near what types of things that you can see even in North America for limulus. As a matter of fact, we had a conference in Hong Kong, and Hong Kong City University of Hong Kong produces about 70,000 juveniles a year, which they're allowed to release. We produce about 10,000 juveniles a year. We've had up to 20,000, but under our permit in New York State, we're not allowed to release them out into the environment. A whole issue there. The coastline is managed for horseshoe crabs, as many other species, by the Atlantic States Marine Fisheries Commission. And I'm going to talk a little bit about that, but this is where they're found. They're not found anywhere else, only on the east sides of continents. And then, again, that has maybe dating back to paleohistory, the Tethys Sea, and plate tectonics. So it is a unique organism in that respect as well. And then, again, the synchrony of bird species, millions of birds, hundreds of species, many of them ruddy turnstones, red knots being listed as endangered in the United States Fish and Wildlife Service, endangered species, under the Endangered Species Act. All of the types of species here literally doubling or tripling their weight, feeding on those billions of horseshoe crab eggs along the coastline. And again, the epicenter, the main population for horseshoe crabs in the United States and the Atlantic coast is Delaware Bay. And I'm going to tell you why that's a good thing, because Delaware Bay, out of all of the states and of all of the areas along for limulus, it is the only place that has a biological preserve, a no-take zone for horseshoe crabs called the Carl Schuster Preserve. And thank goodness for that, because we have no idea. I mean, horseshoe crabs go outside the boundary, which is always a problem, no matter what, if you have any kind of migrating or animal that moves about. So it is a real concern at this point, because these birds are critically important in their migratory patterns to be with enough protein to keep through this their migration efforts. And there's, as I mentioned, there's like a little ecology. I love this shot because I have no clue about how this one animal had so much encrusting organisms on them, but they do have that. And as you can see here, it's just some pictures of them along in the sediment and leaving tracks and trails, you say. We monitor the animals on the beach by measuring across their prosoma, across their compound eyes. There you can see over here the groove, the mating groove on this is a mature female, and there are all types of, the more the better, programs to monitor, track, get an idea about where these animals are. Of course, they have to be, they can't molt anymore if they have these tags on them. Over the years, I've always spoken to people about different types of ways to track mature animals within the 4 species. Very difficult, though there are some new kinds of tags that can be dealt with, not externally, but internally. But again, the molt process changes the animals altogether. They're always brought up in bycatch during the season. Here's one in Jamaica Bay some years ago. Again, the compound eyes, critically important. A Nobel Prize certainly involved with the animal in its visual acuity. It has a number of these ocelli, just like in scallops on the outer side of the scallop. The light sensitive, but the horseshoe crab numbers, as this little slide talks about, really gets to the pressing issue over the last 3 years, and that is its inclusion as an endotoxin detecting system that is almost instantaneous, almost immediate in detecting gram-negative bacteria. And the reason that's so important, even prior to the pandemic, is the fact that gram-negative bacteria in your respiratory system or circulatory system is known as sepsis. And sepsis, there is no particular cure for sepsis. You just have to be very lucky if you do survive. But 3 out of every 5 deaths in hospitals associated with septic infection. And to just give you an idea of how important the blood of the horseshoe crabs are, again, they're basically they're blue. The tint is due to copper rather than in our blood, which is iron-based, hemoglobin and hemocyanin. But the idea is that the medical benefits from bleeding horseshoe crabs, collecting their blood to produce limulus amoebocyte lysate, can't be over discussed and over identified as a pretty important aspect. And here's some just some notes here on the bottom: medical benefits, LAL and TAL from Tachypleus in Asia. And this is a little dated, but a $300 million, it's over $445 million industry today. And it replaces the rabbit pyrogen test, which I'm going to show you in a minute. But in the United States, between 2009 and 2015, in that time period, there were 3.95 billion medical prescriptions dispensed on all subject, everything from vitamins to any kind of prescription. And every one of those prescriptions under a quality control, quality assurance must be tested. Now, there's not somebody just sitting there testing every one of these items. It's called batch testing. And you learn about TAL and LAL and how that works. But it's a very important contamination necessary review for, especially during a pandemic where we have billions of inoculating injectable drugs. To show you how important it was, NASA, when the space shuttle program was active, putting a satellite up, satellites would be coated, if they were communication satellites, they'd be coated in a thin veneer of gold. an outer sheet of gold that would be outside and couldn't have any contamination. They used LAL to find out if there was any kind of bacterial contamination associated with NASA in putting satellites up with the space shuttle. The number of surgeries, 234 million surgeries annually around the world. Millions of surgeries. I'm sure everybody on this call may have had some kind of surgery. It could be minor or whatever, but you can't get bacterial contamination and infection. And it is one of the major concerns that have to do with even the pandemic. You're compromised, immunocompromised. And then, of course, the rise in diabetes and all types of things, more and more people needing to have medications and prescriptions. So there's a service that is important to the overall protection of the animal. And the reason that it's so important, it's not that I'm against rabbits, but the rabbit test was a 24 hours, 48 hours, 72 hours, depending on the concentrations, whether it was inhaled, ingested, or it was on the skin. And then the animal had to have a fever, and it prompted all types of prescriptions after that. You can't wait for 48 hours, 72 hours. It's just not an accurate medical practice. And that's the importance of LAL in getting the blood. This liter bottle at some point runs somewhere in the neighborhood of, in producing LAL, something like $60,000. So it is a commercial operation, and it is a pharmaceutical operation, and the heart is found between the prosoma and the opisthosoma, and it doesn't damage the animal. I've heard everything from 1% to 5% to 30% loss of horseshoe crabs along the coast from bleeding. There's not much. That's very much anecdotal in many respects. You really can't tell whether or not, unless the animals are dead and wash up onto the shore immediately. But the animals are well treated. The pharmaceutical companies don't want these animals damaged, and they return them, supposedly, they're supposed to return them to the same environment that they were collected in. There are 600,000 animals collected in the United States from Maine to Florida each year to bleed. 600,000. There are some physiological things with horseshoe crabs if you get to study them. Mark Bonton at Fordham did a great project dealing with taking juveniles and making slight changes to the carapace and seeing how the damages or the changes in the carapace happen to change and disappear after molt cycles. We got some interesting preliminary information, and we'll be following that in the lab. But here's these two charts bring forth the critical issue. And if you have any following of horseshoe crabs, you know that the Atlantic States Marine Fisheries Commission just proposed releasing in Delaware Bay during the breeding season, proposed to allow harvesting of females and horseshoe crabs for bait. And this is a slide of the main bait. Horseshoe crab baits are mainly used for two fisheries, conch and eel, American eel. But this is the classic conservation story. The conservation story in hunting, in poaching, in overharvesting, is not maintaining sustainable yield on populations on any species on the planet. This is classic. This is the paradigm that happens. Here on the bottom, this bottom chart shows you the landings since 1954 in American eel. And there were times when the populations were sustainable, and they kept taking until around 2000. In the numbers started to dwindle, and this number is still dropping. But notice this dashed line. The dashed line is the value associated with that harvest. And that's the key to what some people call the fisherman's philosophy. If it's there, I'm going to catch it. And that is that this smaller amount doesn't matter what the numbers are, but they bring in a bigger profit. And that's the impact associated with this by taking the animal for bait. There is no reason to have this animal for bait for eel or conch. As a matter of fact, there's no reason to take it for bait at all. The argument has been for 20 years that that's the problem. That we can't find an artificial bait. That's all the reason. The bottom line reason is that when you collect a horseshoe crab, you get a permit from your state conservation agency, and that's free. And therefore you get the bait free. 600,000 animals are freely taken to be chopped up for bait. And they're sold. Sometimes they're sold, or sometimes they're given to bait shops where people can come in and get them right there. But the bottom line is that this is the reason that these animals continue to be taken. And I couldn't believe it when I heard it. It's only a week or two ago that Atlantic States Marine Fisheries Commission came up with this idea and this proposal. Again, the numbers of horseshoe crabs taken, hundreds of thousands. In New York State, 135,000 animals that we know of under permit are taken for bait. And I'm not a betting person, but I'd bet a couple of salaries that there's a lot more of those animals being taken. And it has nothing to do with illegalities. It has to do with the idea that there's no monitoring. There's not as intensive monitoring. It's a tough job. There's not that many conservation officers on Long Island to deal with this, and that's an important factor. Then again, there's disposable things. This is a picture of, again, the fish netting and so on. How to deal with this, it's a totally different issue. But the idea of this animal could possibly be protected, but if you chop it up for bait, you lose it. Now, these two relatively over-enthusiastic students, it's not a problem really holding it by a tail. I think a lot of people get upset about that, but unless you're swinging it around, it's okay periodically to pick them up. But the key here is that there needs to be more attention to getting these animals back into the water if they're seen. Now, I don't know if this animal was even alive at the time, but the key is when you see these animals along the shore, turn them over, get them back into the ocean, and get them back along the coastline. Now we go to the other three species for a moment, because we certainly can learn from this. This has become a global attention to horseshoe crabs. Again, I mentioned about the in Taiwan, and what goes on in Taiwan and Japan and the Asian countries really can't happen in the United States. This is a building built around where the horseshoe crabs migrate through, and they block off the embayments so that they can bring in as many horseshoe crabs as they can. I mean, can you imagine having this in Chesapeake Bay, Jamaica Bay? It just can't happen. So, but the interesting thing about it is that it's part of the culture. They're protecting these animals in many respects. Though there has been, if you go on YouTube, and I guess that's part of the social media onslaught, any animal these days, they've become exotic foods. And so the animals are harvested and they use the shell to hold, like a plate, hold their eggs, and they harvest the eggs as exotic foods. I'm not an advocate of that, but if that becomes something that really becomes a significant advance in culinary arts, I think the animals are really in trouble then. This motley crew here are the key part of this first steering committee for the International Union for the Conservation of Nature, the IUCN. The IUCN is the largest and one of the most prestigious conservation groups in the world. And one of its major functions is it's called the Red List. The Red List is just that. It's a red book that includes all the species that are in critical concern and how you determine that. They meet every 6 years in a Congress. We got Limulus on there. We've got tachypleus, two species on there. We're working on Carcinoscorpius, but the whole idea is to understand their biology. And there's just so much that we don't know about these animals because we only meet them and greet them as they come ashore. This is Mark Botten from Fordham, S.G. Chung and Paul Shin from City University of Hong Kong, Dave Smith from USGS, US Truly, and Glenn Galvery from ERDG, which is the largest really kind of educational center for horseshoe crabs for limulus and involved internationally. And it was through Glenn Galvery's shop and Malloy College that we developed and retained and purchased for Malloy College a K-12 curriculum, full curriculum only on horseshoe crabs. You can get it by just going onto it's free. You can go on to Malloy College's website and the CIRCOM website and get that if your teacher want to use it in your classroom. And this is the Hong Kong system. Again, 70,000 juveniles. They hand feed every single juvenile. They have enough of students, obviously, but it's an amazing functioning operation there. Even with all, obviously, so many things going on in the world and in Hong Kong, but they're still putting out the juveniles in the mud flats outside of Kowloon. This is some of our tanks at CIRCOM. Again, we have captive breeding. This is a single clutch, all right? This is actually two clutches together, over 200,000 eggs. You can see here, there's about 150,000 eggs, a little bit more than normal. This one particular crab here was, believe it or not, was seven years old, and actually 8 years. We had it in the laboratory, and we just lost it last year. Whatever it is, they up to the 10th instar, the 10th molt, and then we lose them. So we're not sure why. Again, here's the third instar, the third molt. Brine shrimp for the hatched species, we give them up to the 7th to the 9th instars. And these are the sites, 115 locations from Brooklyn to Montauk. Again, doing it for 20 years. They're GPS. Here's the first appendage, as I mentioned, for the females, and the males, when they're in amplexus, that small hook. We used to do this. We don't use this anymore. Everything is now digitally. Everything is on a camera. You can take a picture of the beach. We usually survey 1 mile. There have been always comments about CIRCOM's qualitative project. Well, yeah, it maybe is qualitative to some extent. We put numbers on there. Maybe the error bar might be a little bit up, but the trend is important. And here's the trend. Again, this, I'm sorry, I only have up to 2016 on here, but this has gone even a little bit lower in the last 5 years. But this is the trend line, and that hasn't changed at all in this entire time period. And there are peaks here, and this, I'll show you why that's important. The animal has a tremendous site fidelity. It comes back basically to the same location. We don't have, the Florida horseshoe crabs migrating up here. So unless they get caught in a current, maybe, but not that far. The idea is that local populations, therefore, have their emblem by those particular sites, their emblem in those particular habitats. So if it's new housing development comes in and wipes out a couple of acres of marsh, that may be a problem. Or if there's something coming out of the atmosphere, we know a lot. Precipitation in the Northeast has increased a lot. So the idea of hydrology associated with these animals coming ashore. But the critical aspect, and this is increasing, the trend line is increasing, is the numbers of sites in those 115 locations that have for 3 years in a row no breeding animals that we are able to see. Now, did we miss some? This is a generalist statement, but we try to keep it. We get to all these sites. We try to get to them all around. Certainly at the full moon and new moon. There's only 8 days out of the whole season, out of the whole year in which these animals are active and along the shore. And we may not get to all of them, but again, we're looking at this kind of gross evaluation and looking at what couldn't and is not necessarily an acute reaction to loss of habitat, but something is happening in many places. I mean, I hear stories, people call me, talk to me, tell me all the time. I remember when I used to go out to, when I was a kid, had family in Babylon. I would go out to Babylon, we go boating, we go clamming, we go whatever we would be doing on the water. And there would be a beach at the end of the road. And in that, there'd be piled up with eelgrass and tons of horseshoe crabs. And the eelgrass was harvested for fertilizer, and the horseshoe crabs were thrown back into the ocean. But they may have been used for bait. I don't even remember if they were at that time. But the key is that these animals are not coming to the shore in the same numbers, though I've seen even bizarre circumstances above a bulkhead when I was with the Park Service in Jamaica Bay, high tide, bringing horseshoe crabs and actually laying eggs down above a bulkhead. So all types of capabilities for the resiliency of these animals. And to give you an idea, this is a quick look of 8 years, and just look at the top chart here as how this kind of flashing change of concentrations of horseshoe crabs at each of these sites. So it's very difficult to get a tremendous handle on exactly what may be happening overall, but there are two clear pieces of evidence that are irrefutable. One, 600,000 animals are gone, 135,000 of them on Long Island. Two, the idea of the importance of this animal needs to protect its habitat so that we can continue until there's a time. And the story is all the time that there is pharmaceutical use of other endotoxin detecting systems. They do it in Europe. There's several pharmaceutical companies that are applying for this. They have not gotten approval from the Food and Drug Administration. That's the only hurdle at this point, because they're not in any way. And we have a new book coming out. It's due out in end of May right now. We just went through the last 45 research papers from 3 conferences, Japan, China, and anything that wasn't published in previous projects, all talking about horseshoe crabs. And in every case, the idea of the importance of the blood of horseshoe crabs in producing LAL is prime in the protection and the quality control and quality assurances associated with any pharmacological product. Here's the IUCN, the Scientific Specialty Group. Again, the group that I showed you in Hong Kong University, City University, we started the steering committee. We started the steering committee with just the 7 of us. We now have about 15 people on the steering committee, and we have 7 new countries, and we have like 50 scientists working. They were in China. I didn't make it to the China conference in 2019, just before the pandemic hit. I didn't have any predications of that, but it was an amazing conference, and more of the of scientists from China, Japan, Taiwan, and the other Asian countries are looking at this, and they work through the IUCN. Mark Botten and Paul Shin are still chairing the steering committee. They're just terrific scientists and doing great work. Both of Mark worked many years, and as a graduate student with Carl Schuster, the main horseshoe crab person, only passed away a few years ago, and he's surely missed. This is our first horseshoe crab book. This was kind of started. We have 3 new ones after that, dealing with all of the work that's been done. This started at Dowling. And again, we get the species bulletin. If you don't know anything about the IUCN, get on board. It's, yeah, I mean, you name a species. I mean, it's actually, there's a new kind of group movement in IUCN saying, get them off, get the red off, whatever it is, trying to reduce the numbers of animals on the red list. The red list just keeps going more and more, which kind of tells us something about biodiversity on Earth these days. And this is the process. And right up here, this is where, right in this red dotted threatened categories, there's 3 of them: vulnerable, endangered, and then critically endangered. And all 4 species were vulnerable. The Tachypleus are back up here and endangered. And we're not sure if we're going to get to this critical point, but they're definitely in these areas within this threatened category. And I said it takes every 6 years the 6-year Congress, and that you have to apply in that Congress with the policy, and that's what we've been doing for the past 20 years. Okay, what happened? Something froze. Okay, well, things have frozen. I only have 1 or 2 more slides, so.
John, we can still see the slide on our end. I wonder if you press maybe the arrow key right or left or down.
All right. Oh, there we go. Thank you, Russell. Okay, so this is the red list process. As you can see here, it's like any process. It's long streets. Here's the K-12 curriculum for the teachers. It's amazing. It truly is amazing. And we have it at Malloy, but it's free. You can use it, no problems. Just go onto our website and download it. And the key is more study. I know that's always been I remember years and years ago, the first comment that would come to the scientists working on any kind of organism or ecosystem: oh, you're studying it to death. Do you ever learn anything about it? Yeah. The more we learn, the more we don't know. And to be honest, I mean, because of the activities that are going on. But one thing we definitely know, this animal truly represents an amazing survivability, and its relationship to the nearshore ocean and the coastline is of seminal importance. And in many respects, it's kind of a silent siren associated with what's happening to our global coastlines. The United States today, along the east coast of the United States, the population has tripled in my lifetime. The Earth's population in general has doubled in my lifetime. So we're talking about a constant pressure and an idea to keep open spaces and habitat for the organisms that have survived here long before Homo sapien. And hopefully you'll all make a contribution to that. And if you're a teacher, you definitely do. And I thank you for listening to me tonight.
John, thank you so much for this talk. If anyone has a question, we'd love to take them now. Please press the raise hand button if you have a question, and we'll take those one at a time. So while those questions are coming in, I did notice one in the chat, and the question was, for teachers who want horseshoe crabs in the classroom, how and when can they get those eggs for the school year, for the upcoming school year, I suppose?
Thank you, Russell. Yeah, we have something we started. I've been at Malloy for 9 years, and we started it 9 years ago. It's called the Crab Club. All you have to do is email me your school, your teacher that would be interested, the grade, and we get you 1,000 eggs that we collect from those spawns. And we've just given out 28 high schools, 27 high schools, 1,000 eggs, and they take them into, it's really easy to take care of them. And then we just ask that you bring them back if they survive, or you keep records. The students should learn how to keep records. We before the pandemic, we were doing a visit to a school, and we would just do like I just did here. We'd bring animals, and we're going to be bringing. We have a couple of science fairs we're going to in the next month or so, and so we'll be bringing live animals. But the key is having a special place that gets attention every day. You can't leave them. Just change the water periodically. We show you what you feed them. It's not expensive, and you get a big petri dish. You can keep quite a few of them in there. I mean, 1,000 of them fit in a single little test tube. So it's a doable project for any teacher anywhere.
Very well. So I see two hands in the list. First up would be B. DeHarm. Sorry if I don't get that right. Please go ahead. BD.
He doesn't know he's not unmuted.
So that person is unmuted. Your name is BDHARM, and you can ask your question now if you want to. All right, maybe some technical difficulties. So next up would be Paul. Go ahead, Paul.
Hey, I couldn't remember from those dots, but do you have anything going on in Staten Island where you track them?
We don't. We concentrate just on Long Island, but Staten Island has some great kills. It was always a hot spot for horseshoe crabs there. Yeah, they're doing that. The state should be monitoring them. I don't know if they do, but we didn't. We were just concentrating from Brooklyn to Montauk.
So no one collaborates with you on that from that area?
I have never gotten a call on that. I've been involved with a conservation group in Staten Island, and I've given some talks out there, but we don't survey that site, Paul. We don't go out to that. And just like we don't go down the Jersey Shore either, which is when I was with Gateway, we would do it at Sandy Hook, and then we would do it at Staten Island. I was in the Park Service from 1978 to 2001, and we would always look at Staten Island. And they had quite a good on South Beach and in Great Kills population of horseshoe crabs.
I'll check it out.
Okay, cool.
Thank you, Paul. Next up would be Kay. Go ahead, Kay.
So first of all, thank you so much for being an advocate for these wonderful animals. It's so important. In the screen where you showed tank number 12, and you said there's one animal that was 7 years old, did you say?
We had it in the lab for close to 8 years.
And was he small? My question actually is, can you tell when we're walking on the beach, can you kind of guess the size of guess the age of a horseshoe crab by the size of their shell?
Well, first of all, in captivity and bred animals, my experience and everything in Taiwan, their experience, because I asked that question there, the animals don't get as big as they do in the wild. Now, whether they survive in the wild, these animals survive, but they may not have the nurturing and the food resources that they would normally get in the wild if they've bred there and they've been growing there. You can get a sense once they've reached the terminal molt. The females and males are now sexually mature. They are not sexually mature until that time. So once they get to that terminal molt, the 16 and 17 molts in each of the cycles for the female and male, respectively, then you can say, for all intents and purposes, they're at least 9 to 11 years old. Carl Schuster always said to me, the oldest animal that he thought he might have been able to get kind of a sense of on its age was caught off the Jersey Shore, and he thought it was somewhere in the neighborhood of maybe 40 years old. How that is determined by things that are attached to it, by the groove for the breeding groove. So, you know, that was a guess, but no one has kept, you know, a horseshoe crab in a laboratory to see how long it would live. But that's kind of the general thought of it. And the key, though, is once they've gotten to that terminal molt and they're sexually mature and they're starting to become assured to reproduce, that's where the protection comes in. And to be brutally candid, I don't care how old they are. As long as they're surviving and able to produce sperm and egg, then they'll keep going. So at this point, but it's what needs to be preserved, and indirectly, then the age of the animal is the preserve of their habitat, so that there's no taking, no taking out of the Karl Schuster Preserve, and there should be no taking on several beaches anywhere where there's active. I mean, there are some beaches that are truly amazing. They just have lots of animals. You would never think when we had the scientists and colleagues from Asia come to New York back in 2005, and we would go to Jamaica Bay, and right next to Kennedy Airport, two landfills inside, you know, inside an urban impacted estuarine system, and they'd see horseshoe crabs at Plum Beach like you never saw before. They said, wow, that's pretty amazing. And I said, yeah, but why there and not in other places out on the island that are in much supposed better quality environment? We're learning a little bit about the biogenome for the outer portion of the carapaces, dealing with bacterial and fungal coatings of these animals. And there's some hint in there that they're nitrogen processing in some way that helps these animals survive in the waters during the summer months, and maybe even helps them when they get into sediments, because below the surface of most sediments, it's anaerobic, right? So if you're in an anaerobic environment, you want certain types of bacteria like Nitrosomonas and Nitrobacter in the nitrogen cycle to be associated with an animal, rather than having an animal that needs oxygen and would probably decay the animal or impact the animal differently. That is pure conjecture on my part, but it is something that we are interested in looking at, more like the biochemistry and the biogenome of these animals.
Thank you. Am I allowed a backup question, a second question,
Sure.
Russell? Okay. And that when you were showing the trend line, 2011 had this huge peak, almost 8,000. I don't know what you were measuring, pounds or number of animals or something.
Numbers of animals. Right.
Was that just more people out there counting that year, or
No.
just a lot more animals for some reason?
There is a variability in the numbers of because this is a volunteer program. We now have students, right? And they're all chained together to make sure I don't chain. we keep the students involved, and it is student centric, but it is a voluntary thing from day one. At one point we had over 50 volunteers, but the beaches that made the contributions, those beaches are still pretty productive, and not all of them, but many of them are, and that needs a little more analysis. But again, it's the trend line. And we go back to these same beaches. They're GPS, they're all satellite synchronized. We go right to the same location every year.
And so you don't know why there were so many that year? There's no rhyme or reason to it that we know of?
Not that I know of.
Okay. All right. Thank you.
You're welcome.
Questions, Kay. Next up, we have Tom. Go ahead, Tom.
Hi.
Hi.
Hi. So it seems that horseshoe crab is a tough organism because I think you mentioned about its great survivability.
Yep.
Yeah. Can you talk more about the respiratory physiology of this animal? For example, do we know the gas exchange organ? Do they have gills? And can they also survive in like hypoxic environment?
Well, they have what are called book gills, not like the classic gill, but those do need to be in oxygen conditions, and they're very important for the animal survival. Um, the question about being in a hypoxic environment, my experiences have been this, and this was in Jamaica Bay, which has a very deep place called Grassy Bay that was dredged out, and it kind of accumulates a lot of sediment. It's actually called black mayonnaise because it's this kind of muddy organic mix that's down there, which happens to have tons of amphipod tubules, tubes that winter flounder feed on. But winter flounder go into this place, which has lower dissolved oxygen values, never anoxic, slightly hypoxic, 2 or 3 milligrams per liter, but they avoid it. They may not go to that area. You can't, there's no place for the animals to come ashore because you got Kennedy Airport. They go into the head of bay where there's marshes growing like in the year 1000. They're plush. They're in the back portion of the bay's environment, so subject to tidal cycles. So there's a lot of these nuances that determine what animals come back and how they're impacted in the environment, and how an animal reacts in a lab under a lab ex situ could be totally different from in situ in environmental conditions. So I don't even want to venture a guess on that type of thing. But what's really important, I think, is at this point is that there should be sites where they may be coming up there. Maybe they're not as numerous as that big chart that one year, and there may be only slightly small numbers of sites. They have to keep repeating and come back to the same location. We have a paper coming out in the book as a graduate student at Boston College, Boston University, did a project at CERCOM 3 years ago, or more than that already, it's 4 years ago. And she was looking at beachfront changes. She's looked at something like 20 beaches on Long Island and Google Earthed these beaches back to the 1940s and 50s. I'm not going to tell you what the result was, but you got to get the book. No, only kidding. It was amazing how many beaches don't look like the beaches that were in the 1950s and 1940s. I mean, developed, eroded, rip-wrapped, rock jetties, marshes receding, all these types of changes in a 50, 60-year period, 70-year period. Yeah, I mean, it's slow, incremental. Is it a crisis? I don't know. I remember when I was in the Park Service that we were talking about losing acres and acres and acres of marsh grasses in Jamaica Bay. And things seem to be steady. There is some restoration projects ongoing and have been ongoing. Those restoration projects have built up some marshes in some locations. But I'll never, it's like that picture in early 1980s of the Statue of Liberty being at the water and having a swimmy on her arm or something like that under the rising sea level. Environments change, and I'm not denying or talking about these concerns, but when we're looking at the habitat on an island and the types of things that are taking place, it's important to take everything into consideration, and again, their resiliency, even though their numbers are not the indication, it's the habitat, in my estimation, that would be any demise for this animal. And that is, it's different all up and down the coast. Remember, its range is from Maine to Florida and the tip of the Yucatan Peninsula. It could be extirpated on Long Island. You know, it doesn't have to go extinct. It could just be eliminated from the habitat. And a new, and I can report it here, a new impact that I've raised this question to NYSERDA, talking about the wind farms offshore, and said, you're not going to have one windmill. You're not even going to have 10 windmills. You're not even going to have 100 windmills. You may at some point have hundreds of windmills, and each one of them has a transmission line that will be coming ashore, and the shoreline development that's associated with this energy activity is already, take a look, there's a, right out here in Bayshore, there's a bunch of things going on that are getting prepared for this massive, you know, wind energy support. But every one of those power lines comes along on the same paths that these animals have been coming ashore. And I can almost guarantee that throughout the 445 million years that this animal's been on the planet, that they ran into any power cables. All right? And not to be silly about it, but no one is talking to it. No one is answering the question. I said, investigate it. Look into it. I said it 10 years ago. I said it 5 years ago. I said it last month. And it's just, you know, just the screwy scientists talking about horseshoe crabs.
Thank you.
You're welcome.
Thank you, Tom. So I see two more hands. Next would be Joel. Go ahead, Joel.
John, a friend of mine wanted to attend this conference, but had a prior commitment. And I'm wondering if you and Lou could work something out with the NISMIA website that there could be a link for people who weren't able to attend to access so that they could listen to this wonderful presentation.
Yeah, it will be, it'll be online on www.nismia.org. And all the first Thursday webinars we do will be up online.
And you can always visit the CIRCOM Malloy College website. And that's where the K-12 curriculum is. That's where everything about our laboratory. And if you have teachers that are interested in coming by during the summer to see what we're doing with these horseshoe crabs, we're recreating beach fronts. We got these swimming pools. I don't go in the pools. We got all these swimming pools, and they're going to have horseshoe crabs and shorelines with different angles. And again, it's purely ex situ experimentation. And but we will have our students out at these 115 locations. And I'm going on sabbatical in September. So this summer is a time for me to get out to those 100. Last year, 2 years ago, and last year I got out to more than I had to do because we had all the pandemic restrictions. We couldn't have as many students here, and it had to be all socially, you know, separated and everything. But I think this coming year we'll be able to. We already have 4 students already signed up, and one of them is not even a Malloy student coming in from Brockport. So there's a lot of attention to for college students to look at this.
All right. So for the next hand, we have Paul. Go ahead, Paul.
Hey, I was just wondering what they eat in the wild and how you bring that into the laboratory.
Good question. We in the lab we go to any place that we can, like if they're disposing of fish or it's been around for a while, or we go and get some scallops and we grind them up, chop them up, depending on the age, and feed them. We have invertebrate food and brine shrimp for as they get to juvenile stages. In the wild, they're kind of detritophores. They kind of move through the detritus. They try to move into the sediment. They might feed whatever they can get. Remember, their appendages are not like a crustacean, like a lobster or a crab. They are so that they'll move about. when I saw those, the film of the horseshoe crabs grazing on those blue mussels under the Gil Hodges Bridge into Jamaica Bay, any of the, you know how blue mussels, right? There'll be some are dead, some are not dead. And so they're kind of grazing in there. That's basically the types of, most things, invertebrates in sediment can easily be that way. But their food supply has, you know, it's usually in areas that don't have kind of the human traffic. I always used to ask the question from the Corps, people I worked with the Army Corps, if they ever saw in any dredge projects dredging up horseshoe crabs out of an inlet, out of a channel. I don't know if I see Alan. Alan, do you ever hear of anything like that? Like any of the channels having, in a dredge operation, have any horseshoe crab? Because I mean, if you ever watch a dredge project, it's kind of fascinating, but it's really stressful. I mean, you're sucking up all of the sediment out of the channel. And we used to put it on Sandy Hook in New Jersey. We did it sometimes even in Plum Beach and in the Rockaways. And we push, it just gets pumped. And you see, you know, flying, it's not even real flying fish, but their fish are flying. They're coming out of there because they're taking them out of the channel. And if it's at a certain time, they're supposed to be careful of that. And they're not supposed to be in there, but they could graze. It would be prime location to graze in channels, because again, they move through that kind of easy detrital material to move through, and that could happen, but I've never witnessed it.
All right, so one more question from the chat. It was a question that we were trying to get earlier.
Okay.
Does a teacher need a saltwater tank in the classroom already if they want to accept eggs?
You
Or-
can have, if you have a saltwater tank, yeah, that's all you need. But again, you can't have any other animals in there. So this will be food instantaneously. And then I'll have, if anybody's interested, you can just contact my tech, Kyle Morelli. Kyle will handle all of that. He's the crab club coordinator. The school gets a certificate, and then hopefully this year, it'll be the first time over the last 3 years anyway, that at the end of the school year in June, if there are juveniles or hatch animals, we bring them back here, and I go through my annual barbecue on the dock. So, and you're all invited. So.
Well, I want to thank you, John. That was really great. It was a really great presentation.
Thank you, Lou.
Yeah, one of our ideas here is to try and keep this sort of teacher related. And one of the great things about the horseshoe crab eggs is they're available in May and June. And a lot of times teachers are looking for something to do those last couple of weeks in school. If you can get out and collect the eggs, and then if you get 500 eggs, separate them into 20 different sections and try subjecting them to different pH water, different temperature water, different light water, you have a perfect experiment to do.
Yep.
And see how many of the eggs develop, how far they develop, whether or not they hatch out. It's a great exercise. You don't really need a microscope. You can use magnifying glasses in the lower grades. And the last thing I'll tell you about that is 40 years ago at John Dewey High School, we used to go out and we used to milk the eggs and sperm from the horseshoe crabs and put the eggs and sperm together, and we'd have developing groups of horseshoe crabs that were all from the same parents. Around that time, we went to one of the colleges that I won't mention on Long Island. And we were talking with the chairperson of the Marine Science Department, who was telling us about these wonderful experiments that he was doing But I forget exactly what the experiment was, but the problem is that the eggs all came in batches and they weren't sure if they were from the same parents or not. And I said to him, well, why don't you just milk the eggs and sperm, and that way you know they're coming from the same parents? And he said, oh, you can't do that. And the kids in my class looked at him like, we have experiments like that running in the class. So you can do great things in junior high school and high school classes. You just have to get out there and do it. And hopefully John has given you some ideas of different things to do. And I just want to show you, John.
Oh, my goodness. Oh, yeah.
Yeah, there you go.
Okay.
This is the T-shirt from, was this the first conference?
That was the first one. Yeah.
This was the first one at,
Paul Schuster did that logo.
right. And he actually came to the conference, right?
Yep.
Didn't he? Or
Yep.
he was, yeah.
No, he was there.
Yeah, it was a
Sylvia,
wonderful,
Sylvia Earle was there.
right. It was a wonderful, wonderful conference. We had, I was working with John at the time, so we had earphones for the people and translation, because a lot of the people were from Japan and China and the Philippines, and it was a really great conference. John, you've done a great job all the years, and thank you for doing this. And it will go up on the NSMEA website. I just want to put in a plug that in July, we're hosting the National Marine Education Association Conference. It's going to be a hybrid conference at Hofstra University. And it should be very interesting. We're going to have a lot of fun, some field trips, and there will be a student conference component to it. So if you're interested in it, just look at nismea.org and you'll be able to find out all about it.
And if I could add to that, Lou, thank you. That the Hofstra conference does have a field section day. So if you register for the whole conference, I think it's the Thursday of the event. You can get a chance to come out to CERCOM and visit the Horseshoe Crab Lab. And then if I could just one little thing, I guess, about Earth Day, April 22nd. We are hosting, it's virtual, but you can register for it. It is called the Long Island Eco Summit, and we have 18 presentations starting.
It's a great lineup. Yeah,
it really is 9 o'clock until 5, and you can come in and out anytime you want, talking about everything from whales to horseshoe crabs. So it is it's actually everyone on here is a positive contribution to the Long Island ecology and environment. And NSMEA, if you're not a member of NSMEA, you should be. And Lou and Lisa, thank you so much for everything you're doing. This is it's a great thing to do. Get more people to talk about what they're doing. A lot of good stuff going on.
And lastly, I want to be sure to thank Russ for organizing this, putting it up, making the video available, and so. Okay, so it's been really great. We'll see you, folks.
Thanks, Lou.
Thank you.
Thanks, Russ.